Welcome back. We are still working on section 4.7 about linear rational functions. We're going to have another day, actually about 2 more days on this topic to make sure we can talk through every kind of possibility there is. So to start, can I please have you pause the video and try these 2 problems? Please use your rules for graphing rational functions. Follow those 8 steps. Good luck. Okay, hopefully you paused it. I'm going to go through it now in detail and you can kind of self-assess how you did. So first step on my sheet says factor the top and bottom. Well, I notice in the top I can factor out a 2. Not sure how well or how helpful this is, but that's something I can do. Step 2 is wholes. Can I cancel something from the top and the bottom? Sadly, no. So no wholes. Step 3 is vertical asymptotes. What makes the denominator equal to 0? So vertical asymptote, all I have to do is set the denominator equal to 0. So that means I have a vertical asymptote at x equals 1. Okay, right away I'm just going to graph that. So at x equals 1 I have this nice dashed line that I cannot cross. Then step 4 is horizontal asymptote. Well, horizontal asymptotes, I have 3 different cases. The degree of the numerator can be less than the degree of the denominator, the degrees of the numerator and denominator are equal, or the numerator is bigger than the denominator degree. Well, in this case, notice they're both power 1. So my horizontal asymptote is case B, where they're equal. So horizontal asymptote, the degrees are equal, which means you take the ratio of the coefficients, which means it's going to be y equals 4 divided by 1, or just 4. So that is my horizontal asymptote, based on the fact that the powers, the degrees here, are the same. So at y equals 4, I'm going to have a nice dashed line. I go to step 5, where is the numerator equal to 0? This is my x-intercept. So we have x-intercept is just when is the numerator equal to 0? So 4x minus 2, when does that equal 0? Oops. When you solve that, you'll get plus 2 divided by 4, so x would equal 1/2. Remember, this is a coordinate point, so 1/2 comma 0. Is our point. So that's right here. Step 6, y-intercept. So I'm going to set x equal to 0 and solve for y. So now, run out of room, guys, sorry. Y-intercept, you take your equation and set x equal to 0 every time you see it. So the y-intercept would be negative 2 over negative 1. So y would equal positive 2. It is a coordinate point, so this is what we would graph. 0, 2. Voila. Well, looking at this, I kind of can get an idea of what this shape is going to look like. I see that it's going to hug this asymptote, come up here and hug this asymptote. Please make it clear that it gets super, super close, but it will not cross. Okay. Now, once we go on to number 7, we look at the multiplicity, the power the term is raised to. Well, I already have my first curve here. If I look at my vertical asymptote, so looking at my denominator here, this power in the bottom is an imaginary 1. So it's an odd power. Odd means you need to approach in different directions. So as I come from the left, I'm heading down, which means as I come to the right, I need to head up. So that would be my graph. If you would like to verify, maybe do an XY table, find a point in that top right area, but you do need both of those lines, both those curves and the asymptotes. If you made any mistakes, please go back and correct them. This next one, hopefully you tried this one on your own. We're going to take it step by step again. So first step is to factor top and bottom. Nothing can factor, which means for number 2, nothing will cancel out, so you have no holes. Now we're on to step 3. Vertical asymptotes. What makes the denominator equal to 0? So the vertical asymptote is at x equals 4. I'm going to graph that line here. This is the vertical line I will not be able to cross. Step 4 is the horizontal asymptote. We look at the powers of the numerator and denominator. If you notice, you could really put an x to the 0 here. If you wanted, it would go away. But just if you're trying to compare the powers for your horizontal asymptote, you notice the denominator's power is bigger than the numerator, which that is section A. The degree of the numerator is less than degree of denominator, which means this y equals 0 is going to be your horizontal asymptote, no matter what. Here is that horizontal asymptote. Then we move on to step 5, x-intercept. When is the numerator equal to 0? So x-intercept, numerator equal to 0. Well, when does -1 equal 0? Never. So there's actually no x-intercept. And that's okay. It's just saying it's not going to cross that x-axis. Totally fine. Y-intercept is number 6. You set x equal to 0 and solve for y. So y-intercept, it's going to look like y equals -1. There's an x, put a 0. So my y-intercept is -1 over -4, or 1/4. It is a point, 0, 1/4. So we'll graph that. Now we have to look at multiplicity. So looking at this graph, I kind of have the idea that it's going to hug this curve and then go up. That's my idea. I could verify with an XY table. It's probably a good idea to do so. I'm now going to look at the multiplicity of my vertical asymptote. It was 1. So since it's an odd multiplicity, I approach to the right and I go up, which means as I approach to the left, I need to go down. Please correct any elements that you got a little confused on. Now, moving on a little bit, we're going to take a function that looks like this. F of x equals 1 over x cubed. What should that look like? And then we're going to sketch it when I have a -4 and -2 in there. So, quick recap, this function should look something like so. Again, this is from our power functions that we know, learn, and love. And now we're going to plug in. Ooh, we have to notice that it's negative right here. That's crucial, so it's actually going to be the opposite of this. But let's kind of look at the steps. Step 1, factor top and bottom. Can't do that. Step 2, cancel out any holes. Nope, can't do that. Vertical asymptote, what makes the denominator equal to 0? So vertical asymptote, denominator equal to 0. I can just take that cube root, get rid of it. So x equals 2 will be my vertical asymptote. And please just have that sheet next to you with all the rules. Horizontal asymptote is next. We look at the power of the top and the bottom. Hopefully it's very clear to you that the denominator's power is bigger than the numerator. There's actually no exponent degree in the numerator. So this is the case where the bottom is bigger. So your horizontal asymptote will be y equals 0. That is case B. There we go, making our graph. Next could be the x-intercept. X-intercept is when the numerator equals 0. Well, as we did before, we notice there's not going to be one because -4 will never equal 0. So we have no x-intercept, which is fine. y-intercept, we can solve for that. It would be y equals -4 over 0 minus 2 cubed. -4. -2 to the third power is -8. So I would get +1/2. That's the coordinate point here. You can graph that. And kind of looking at it, I think I could get a curve that looks like so. Right, hugs that asymptote. Looking at the power of that denominator, my vertical asymptote, I see it's a power 3, which is odd. Since it's odd, I can expect to see the graph go like so. Now, moving forward, as we get into more intense graphs, I am going to require an XY table. It's really not that bad, my dears. It will guarantee that you have the correct equation and the correct shape and make sure you're all good to go. So for example, let's say I choose the point 1. If I plug in 1 to the original equation, I get out 4. So 1, 4. Okay, so that means I actually can clean up my line a little bit, my curve. But it still has that shape idea I was talking about. It's going up. If I plug in maybe a point to the right, because you want to see this bottom curve, what it looks like, what if I pick 3? If I plug in 3, I get -4. So that's 3, -4. Oh, I was actually pretty close on that. I'm just going to take this, move it over to it. And then you're guaranteed you have the correct curves. Okay. Second one, where does a function cross the horizontal asymptote? This is step 8. So I mentioned it before, but now we're going to really have to focus in on this. Step 8 of that function rules. Where does a function cross the horizontal asymptote? So this one, all it wants us to do is find where it crosses, but let's actually go a little bit more, right? This is honors pre-calc. Let's actually graph it, and then we'll show where everything happens. So let's start from the beginning. Oh, this thing is big, so I'm going to rewrite it. Let's put our numerator, our denominator. Oops, if only I could write. Step 1 says to factor. I can factor the top to be x minus 1, x plus 3. The denominator I can factor to x minus 2, x plus 1. So step 2, looking for holes. There's not going to be any because there's no common factors that I can cancel. So I jump to horizontal asymptotes now. I'm sorry, vertical asymptotes. Jumping again. Vertical asymptote is when the denominator equals 0. Hopefully you can tell that the denominator will equal 0 at x equals +2 and at x equals -1. It's a nice zero product property problem. So I'm going to graph those two. I have -1, I have 2. Horizontal asymptotes are up next. Horizontal asymptote, we look at the fact that the power on the top and the bottom are equal. When they're equal, you're going to take the coefficients in front, which is 1 and 1. So horizontal asymptote equals 1. Y equals 1. Graph that. Next up, x-intercept. When the numerator equals 0. So multiple ways to do it. You could set from the beginning equal to 0 or the zero product property equal to 0. It doesn't matter to us. Pick what works best for you. I think it's easiest for x-intercept numerator equals 0. I think in factored form, right? So I can just go 0 equals x minus 1, x plus 3. Oops, come on. Now it's a nice zero product property. So x will equal 1. And x would equal -3. These are the coordinate points, 1, 0, -3, 0. So this is 1, 0, -3, 0. Y-intercepts are next. Set x equal to 0 and solve. I think in this case it might be easier to use the original equation, because then you can do 0 squared plus 2 times 0 minus 3 all over 0 squared minus 0 minus 2. So I'm getting -3 over -2, which is 3/2. So the point 0, 3/2 is what I can graph for my y-intercept, which is about 1.5. Now we have to look at multiplicity. So multiplicity of my denominator, of my vertical asymptotes, both are odd. If you look right here, they're both 1, power 1. So both are odd, which means you need to approach in opposite directions. Now it's kind of hard to see what this is going to look like. I think maybe I might go like this, right? Hug it. Which means if it's odd and I'm approaching down, this one needs to approach up. Maybe it'll look something like this, where I go down. Since this one goes down, I know that this one needs to approach going up. But again, this is just an idea. This is just a guess. So you need to use an XY table, okay, and verify. Now the last part right here is, when does it cross the horizontal? That's the whole point of what we're doing. Well, if you look at step 8, where does the function cross the horizontal asymptote? You set the function equal to the value of the horizontal asymptote and solve. Okay, well, here is the function. Here's your horizontal asymptote. If we set those equal, we can find where it crosses. I'm hoping it's going to be this point right here, right? That's where it crosses the horizontal. If it doesn't, then I need to reconfigure my entire graph. So let's show that. We'll do it down here a little bit. I'm going to set my function equal to my horizontal. So 1 is going to equal x minus 1, x plus 3, x minus 2, x plus 1. Here I can do a nice over 1 cross multiply. As I cross multiply, I'm actually also going to FOIL. I just think this might be a little bit easier for us. It is, because when I'm starting to solve, these will cancel out. Bada bing, bada boom. I would get 3x equals 1, so x equals 1/3. So it's saying at x is 1/3, the y value of 1, that's my horizontal asymptote, this is where it should cross the horizontal asymptote. Notice the y value is the horizontal asymptote. If I'm correct, that's about 1/3 1. Yep, right there. Okay, so I will be requiring you to now do XY tables as well as check if it ever crosses that horizontal asymptote. Okay, I know this is long, but this is a lot of practice and we need it. Last one, if you feel confident, please try it on your own and then we can verify in the end. Okay, first thing, we want to factor top and bottom. Can't do that. Can't cancel, so no holes. Next is vertical asymptote. With vertical asymptote, what makes the denominator equal to 0? I have x equals +3. Right away, just graph that in. It's where you cannot cross. Horizontal asymptotes up next. Look at the powers, which are both 1. So since they're the same, I'm just going to do 3 divided by 1, that coefficient. So y equals 3 is going to be my horizontal. X-intercept, I'm just following these steps, my dears. X-intercept, numerator equal to 0. So I get the coordinate point, negative 2/3, 0. Y-intercept, just plug x equal to 0. My y-intercept is 0, negative 2/3. Looking at the multiplicity of my denominator, that will tell us that it's odd because it's raised to the first power. So we need to approach in different directions. So as I'm here, it kind of looks like I'm going to go like this and hug these asymptotes, which means I would have to go like this and approach in opposite direction to that blue dotted line. When in doubt, make that XY table, confirm. And then let's quickly check, does it cross the horizontal asymptote? Let's do that step 8. Do it right here. So step 8, we're going to verify that it will not cross the horizontal, because in my graph it doesn't look like it will. But let's make sure. That means you take your function, which is 3x plus 2 over x minus 3, and you set it equal to the horizontal asymptote. In this case, it's 3. Okay, I'm going to put this over 1. Let's cross multiply. Get 3x minus 9 equals 3x plus 2. Realize that these x's will cancel, and you'll be left with negative 9 equals 2. Well, that's not true, so it doesn't cross the horizontal asymptote. Okay. So please make sure you are taking this very, very slow. You're using that rules for graphing rational function, and I'll answer any questions during class. Good job, peeps.